Hi everyone! In this video I'm going to show you how to solve quadratic inequalities in one variable and plot them on a number line. So basically this is the same basic skill as solving a quadratic equation, except that there's going to be like one or two extra steps at the end, because it's not just the zeros we care about, it's what happens around the zeros that we care about. So I think it's easiest if I just jump in and show you an example, pretty much as usual. So for the first one, let me just give you one that's already factored. So 2x plus 5 times, let's do x minus 3, and let's make this less than 0, say. Okay, so one thing, same as always, you need to have 0 on one side of your equation, because that's what you care about, finding the zeros, because we're using the zero property of quadratics, right? So the zeros from this are going to be the positive 5 becomes negative 5, right? So it's x equals, the positive 5 becomes negative 5, and the 2 in front we're dividing by. So negative 5 over 2, and then the negative 3 just becomes a positive 3. So those are the two zeros for our quadratic. Now I'm not going to sketch the full quadratic function. All that I care about are, well, usually we'll throw 0 in the middle, but the 2 points we care about are negative 5 over 2 and positive 3. And generally speaking, you should throw 0 in. You'll notice I'm not doing this to scale, like 3 is only like slightly more than negative 5 over 2. It really doesn't matter. All that we care about is what's to the left of what's to the right of what. Beyond that, it's fine. Now there's two ways you can approach this. One way, which is really kind of slick, is you can just pick a point, any point sort of in these intervals, and figure out what happens. Like really what we care about is what happens to the left of negative 5 over 2, what happens between negative 5 over 2 and 3, and what happens to the right of 3. And if we can figure out what happens in those three intervals, we can figure out if our function is above 0 or below 0. So that's what we're going to do. One way you can do it is you can actually just plug numbers in from these intervals. Like 0 is a really nice, easy number on this interval. So let's plug 0 into our function and see what happens. So if we have 2 times 0 plus 5 times 0 minus 3, usually I wouldn't even write this, right? I know my x terms are going to disappear. All that I care about is the constants from my original function. So positive 5 times negative 3 is negative. I don't even care what value it is. All that I care about is it above or is it below the x-axis. So down here it's going to be below. So in this interval it's below. And since we know our quadratic shape pretty well by now, if it's got a 0 here, it's going to be a hollow point here, right? Because it's less than, not equal to. We're going to have a hollow point here because that's where it's exactly equal to 0, which we don't want to include. And it's negative down here somewhere. Then all that we care about is that our parabola shape is going to look like this. So I don't even need to check points on this sort of blue interval to the left here, or this pinker interval to the right here, because I know for sure that they are going to be positive and positive. And just as a really quick check, the nice thing about this idea of going off forever is you can actually plug in a really big number. And the nice thing about plugging in a really big number is that most of the stuff sort of disappears. Like if I imagine plugging, so let me just rewrite my equation again to show you what I mean, because this is really cool. 2x plus 5 times x minus 3. If I imagine plugging like 1,000 in for x, right? 1,000 is a nice big positive number. If I imagine plugging 1,000 in for x, then this first bracket is roughly 2,000, and this second bracket is roughly 1,000. The plus 5, negative 3 don't really matter if all I care about is what's happening in this positive case. So I'm going to get roughly 2,000 times 1,000, which is, I don't even care that it's 2 million. All that I care about is that it's a big positive times a big positive makes an even bigger positive. So it's definitely going to be positive over here. And if I just imagine plugging in negative 1,000 and negative 1,000, this is like negative thousands, this is in the negative thousands, and negative thousands times negative thousands is positive millions. So again, we're just going to get positive there. So you don't need to get like super fancy. You don't need to like plug in, oh, it's negative 5 over 2, so I'm going to plug in negative 7 over 2 and carefully go through blah, 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 blah. No, we don't need that. All that we care about is it more or less than 0? Okay, and we figured that out. So we know that we want it's less than 0 where? It's less than 0 on this interval, hollow point between negative 5 over 2 and 3. And so our final solution is negative 5 over 2 is, don't know why it's not drawing. Let's try this again. Negative 5 over 2 is less than x is less than 3. So x is in that interval. That's one way to write it. The other way would be to actually show it on a number line. Negative 5 over 2, 3, let's throw 0 in the middle. And so then we're going to do hollow to hollow with a line connecting the two. Okay, so there's our solution. Let's try one that's not already factored for you, because realistically that's a little bit too easy. Let's do one where it's 3x minus 42 is greater than or equal to negative x squared plus 4x. Now, first of all, we need to get this having 0 on one side or the other. And because of this negative sign right here, I'm actually going to make it 0 on the right-hand side. Because having a negative leading coefficient is kind of ugly and hard, and it makes a lot of things complicated. So don't make it a negative leading coefficient. Just move it to the side that makes it a positive leading coefficient. So I'm going to bring my x squared term over here. And when I bring my positive 4 to the other side, it's negative. So 3 minus 4 is negative x, and negative 42 is just chilling. And this looks like something that'll factor really nicely. And in fact, what are two numbers that multiply to 42? If you know your times tables really well, then 6 and 7 should sort of jump out at you. And sure enough, positive 6 and negative 7 give you your two factors. So now that we've got our things factored, we can plot this on our number line. And I'm going to show you another way of finding our intervals now. So this is going to be x equals negative 6, x equals 7 are our zeros. So negative 6 is here, and I guess 0 is in the middle, and 7's over here somewhere. And since it's greater than or equal to, I know I'm going to have solid points, so I'm going to fill those in now. And another way of doing this, instead of plugging in like sample points, you can just look at the leading coefficient, right? So this sort of like invisible number here is positive, well, positive 1. And since it's positive, like if we were sketching this, we know that our parabola opens up, right? Because positive leading coefficient means that it opens in the up direction. If this was a negative sign in front, if it was negative x squared whatever, right, the rest we don't really care about. If it was negative x squared, then it would open down. So we can then fill in this sketch of our parabola, looks something like this. And we care where it is greater than or equal to 0. So we want to the left and we want to the right. We do not want in the middle. So that means that x is less than or equal to negative 6, or x is greater than or equal to 7. Those are sort of our inequality symbols. Or we could do this just on a number line, and we'll just basically redraw our number line above, just nice and clean without our parabola sketch getting in the way. And so we're going to do solid point to the left and solid point to the right. There's a solution. Okay, so those are two that can factor, and I think most of the practice I've given you is stuff that can factor, but I just want to show you guys that this idea of zeros of quadratics is kind of important. So let's do ones that don't factor. So let's do 2x squared minus 11x plus 3 less than or equal to 0. Okay, so 2 times, right, if we were trying to factor this, we need two things that multiply to 6 and add to 11. Nothing multiplies to 6 and adds to 11. Okay, so this does not factor. So what we're going to have to do is we're going to have to go to our handy dandy quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a, right? Everyone's favorite Pop Goes the Weasel formula. So all I'm going to do, this is my a, this is my b, this is my c. Let's plug those three values in and see what we get. So x equals negative, so negative 11 makes it positive 11, plus or minus root b squared is 121, because that's 11 squared, minus, I can do this in my head, 4 times 2 times 3. Well, 4 times 2 is 8, and 3 times 8 is 24. And it's going to be minus 24 because it's right positive, positive, positive with a minus sign in front. So there is my inside of my discriminant part, right, is the part inside the radical. And then 2 times 2 I can do in my head as well. I'm guessing you can do 2 times 2 in your head as well. So x equals 11 plus or minus 121 minus 24. Well, taking 21 away would get me to 100, so I need to take 3 more away. So that's 97 over 4. Now root 97 is really close to root 100, so that's 10-ish, right? So root 97 is about 10. Not really super important, but it's nice for placing on the number line. In particular, I'm going to care whether or not I'm right or left of 0. Right? 0 is often a point we care about on our number line. And so since I know that this is going to be 11 minus 10, it's still going to be positive. Right? And I know it's less than 10. It's like 9.9 or something. But like really all that I care about is it's going to be still positive. So on my number line, I'm going to plot these 2 points. I've got one option is 11 minus root 97 over 4. And the other point is going to be 11 plus root 97 over 4. And 0 is going to be over here-ish somewhere, because I know that this point is about, well, 11 minus 10 is 1, so that's roughly 1 over 4. And 11 plus 10 is 21. 21 over 4 is about 5 1/4-ish. And now all I need to do is just fill in my shape in between. And I'm actually just plug in 0, because 0 is a really nice number to plug in. So if I plug 0 in for this, 0, this disappears, 0, this disappears, so I get 3. Is 3 less than 0? No, 3 is positive. So up here it's like 0, 3. Let's change colors actually. Okay, up here is 0, 3. So then my parabola shape then must do something like this. Right, just knowing one point is enough. By knowing one point that is positive here, when it goes through the 0, it's going to switch. And when it goes through the 0 here, it's going to switch. And I think I said less than or equal to. So my points on my number line are both going to be solid points because we're including those values. And I want less than. So less than is the interval here between the 2 points. So if I'm doing x between, I'll do x between, and then whatever my radical is. So 11 minus root 97 over 4, and 11 plus root 97 over 4. Or a number line, which I'll skip for the sake of time. Okay, one more. This last one's quick. So we're just going to do x squared plus 5 is greater than negative 2x. Now, of course, I can't solve this so long as one side is not 0. So the obvious way, since we've got a positive leading coefficient here, let's put the 0 on the right-hand side again. So x squared plus 2x plus 5. What multiplies to 5 and adds to 2? Nothing. So we can't factor this, so we're going to go to our handy-dandy pop goes the weasel. Quadratic formula. X equals negative b plus or minus square root b squared minus 4ac. Wait a second. I don't even need to keep going. That's negative. Since that's negative, I can just stop right now. I've got a negative discriminant, which means how many solutions do I have? There are no zeros. There's no zeros, and it's opening, since that's positive, and it opens up, right? So the fact that there's no zeros gives us 2 possible shapes, right? No zeros could be, it could be like a parabola up here, or it could be a parabola down here. But since it opens up, we know it's not this, it's got to be that one. So where is a parabola that's above the axis greater than 0? Everywhere. So this is true everywhere. And because mathematicians like to be really confusing, well, there's other reasons for it too. It's pretty precise and technical and all that. What we would say is we'd say that x can be any number, so x is an element of the reals. And if you want to be super fancy, you can say the set of x values where x is an element of the reals. Yeah, that just means that any possible number. And on a number line, the number line looks kind of silly for this one. We're going to put 0 in the middle. We don't have any particular points we care about. So all that we're going to do is we're just going to put an arrow over the whole number line. Not a very useful graph. Okay, there you have it. That is how you solve quadratic inequalities in one variable.